Remember, diameter and rigidity is what it's all about, baby.
That's right.
Leave it alone.
That's right. The length really doesn't matter.
And you got your strike hold with the extension tip.
Right.
5, 4, 3.
Hi, I'm Ken.
And I'm John.
Oh.
Hey,
What happened?
don't adjust your sets. The gray is gone. It's a new year.
Oh.
I'm 20 years younger.
And driving the women wild.
Yes, no more gray. I just washed it away. I'm John, and we're all about tools.
All right. Well,
Happy New Year to everybody. Glad you could join us tonight, or join our archives.
yeah, our archives seem to be very
And
popular.
actually, our archives are being watched probably 400 to 500% more than the show.
That's amazing.
Which is really, really cool. We're glad you guys are using it. We're getting a lot of calls saying that they've gone over and over different tools and they're starting to purchase. And it's wonderful. We're really glad that there's an opportunity for you to really see the tool in action. And that's
Another great thing about the archive, too, is I'm told by a lot of guys, they may not necessarily want to watch the whole show, but you're able to watch just the segments sometimes that you want, which will really help you to get the information you may need quickly just because of time constraints. So that's certainly available in the archives also.
That's right. And our producer, Chris, is working on a searchable video database.
Which means?
Well, it's kind of like YouTube or something, where you'll be able to go onto it and just type in, say, the word router, and every segment that has a router shown on it will be listed, and then you can pick whichever one you want to watch. We'll have a description on it and what have you. It's pretty sophisticated.
Well,
and
it's interesting you were talking about routers.
if Chris ever gets it done, we'll be all set.
Well, you know, it's hard to get him to work.
Yeah.
But it's interesting you would say routers because tonight, as we said last week, we're going to be talking all about blades and bits. So
Cutting tools.
yeah, anything to do with cutting for the most part. And the thing that I find kind of exciting about this, it's not the most exciting thing to watch. We're not going to cut our hands off, we hope, tonight, although cool things could happen. but it's a chance to learn about a topic that most guys never take a chance to learn. So you really don't know what you're buying when you buy something at the home center, something from the saw salesman, or even if you go online and buy it from somebody like Specialty Tools. So hopefully this will help you out there to make really good decisions when you're buying something. You really can begin to understand what it is you're getting.
And we're not actually going to go over every tooth configuration, every type of blade available, because there's hundreds available. There's a lot of manufacturers. We're going to talk about basics. We're going to talk about basics. That's another cutting that we can... Anyway, we're going to talk about basics on blades, basic configurations, why a blade does this and why it doesn't, why it should cut solid surface versus wood versus high-pressure laminate. But we're not going to go over every manufacturer. If we leave anybody out, we're sorry. That's not our intent.
But essentially, everybody is kind of repetitive to each other.
Right.
So if we cover one style of blade, we've really given you the basics, and you should be able to make a good decision with some of the basic knowledge, really knowing what to look for in making a good blade.
Yep.
First, we're going to talk about saw blades in this first 20-minute segment. And I know we're going to have really time constraint like we have every week, because once we get going, there's just so much to tell you.
By the way, before we get started, all of our pictures and a lot of our literature was taken off the Amana website. We thank you for that being up there. If you need to learn anything about cutting tools, Amana has some really good tips up there and a lot of direction as to what blade cuts what as well. And we got a lot of information from Velopec as well tonight.
Mm-hmm. Yeah, and they were all great.
Right.
All good to work with. First of all, we're going to talk about generally what goes into a saw blade. There's so much, and we're all familiar with going to the home center and you buy a tool and they toss in really a throwaway blade. And some of the thing that makes a throwaway blade versus a keepable blade, and I'll just grab one of these right here. This right here is a alternating, it's an ATB blade, alternating tooth.
Top bevel.
Top bevel, that's it, alternating top bevel.
Right.
So, and this blade here,
And what does that mean, Ken?
Alternating top bevel?
Right.
That means, well, we're going to get to that in a second. Don't we have one of our nifty drawings?
Well, we don't really, but we can get into it now.
Okay. Alternating top bevel, really what that means is the blade itself, the tooth will be shaped this way on one, and on the next one it's shaped like that.
That's right.
So it goes back and forth.
Right.
And that's alternating
Top
bevel. There we go. And there's also a high alternating top bevel,
right,
which is a variation. We'll talk a little bit about that.
Right. Primarily used for laminates.
But one of the things I wanted to point out, on a really good quality blade, one of the things you'll look for is the presence of a good amount of carbide. The cheap blades tend to give you very little carbide. More than likely, it tends to be a poor quality carbide, and we'll talk a little bit about that later on, what makes carbide good or bad.
But they're really designed to be thrown away.
Exactly.
You know, if you go into, you know, one of the hardware stores or what have you and gets the $9 blade or what have you, they're designed to cut through nails and staples and things like that, and you just toss them away.
Correct. Whereas a blade like this is designed to be sharpened multiple times.
Right.
So over and over. So this blade would certainly cost more. The benefit to it, though, is you're not going to be buying blades as often,
right,
and you're going to get a consistent performer in your shop. And consistency in performance is probably almost one of the most critical components of a good blade to begin with.
It's good in anything.
That's correct. Another thing that you really wouldn't think that much about, but I think is incredibly humorous, is the arbor hole. The positioning of the arbor hole is critical. You don't want your blade to cut like this.
Okay, I would assume it needs to be in the
jigsaw
center.
action blade is not what you're after.
Right.
But I was amazed to find out really just being off by hundredths of an inch on the placement of the arbor hole the arbor hole. I'm sorry, thousandths of an inch is just a frightful error.
And that causes what's called run out on the blade. So it kind of, like sometimes you get your tire on your car doing that, you know.
Bobbleheads. I've seen bobbleheads do that too.
Yeah, there should be no run out.
Correct.
I think as a matter of fact, I think that on the Amana blade on their website, their maximum run out is .002. So it's maximum of 0.002, which is not much.
Correct.
I mean, that's the thickness of a hair, I think.
And especially, once again, where they talk this is so critical to the performance, it will stress your saw, it will stress the arbor on your saw motor. So it's a critical thing. Another thing that is kind of fascinating are these expansion slots. Right here. Nifty little expansion. See the expansion slot?
Looks like a little C in there.
Tell us what the expansion slot's for.
Actually, it's for, it's just that. It's expansion. When the blade runs and heats up, the blade is going to get larger and smaller in diameter by way of heat, and it allows the blade to expand without distorting. Because if it distorts, it's not going to cut properly. Now, tell them what's cool about an expansion slot.
One of the things I learned, and if you could hold a different blade up.
Here, let me look at, we'll
just
right
grab a
Festool blade. This one.
Okay, right under there.
Okay.
Is a good example.
We're talking about teeth, by the way,
originally, but we've already gone past that point because we got to keep moving. Right under here.
We won't worry about these. We were going to have nice pictures up here for you, but anyway, this expansion slot is on a blade by Popular Tools, and if you can see, they're completely different. And some of them end with a hole, and some of them don't. And some of them are shaped like a C, and this one's got a squiggly in it.
And they're cut by lasers.
Right.
Why are they different?
I don't know. Could it be a signature of the manufacturer, possibly?
That is something I found out. Every manufacturer tends to cut a different configuration, slightly unique to that manufacturer. There's no benefit to it. There's not like one is better than another, which was my thought. If this saw does it like that, it's got to be better than another. But even within a manufacturer, if I can hold one of these up and you can show.
Now, these are two different as well. Now, I'm just wondering if these are made by two different companies for Festool, possibly.
Could be.
And if that were true, then that would really pinpoint the fact that these are a signature for each manufacturer. But anyway, they actually just perform the expansion.
Correct. They allow the blade to heat up without beginning to warp or distort. And that's very critical. Now, another nice thing that's added to the saw that helps in its performance is the size of the gullet, right in here.
Right.
Now, we have a gullet of one size here. If you could just hold this here, and we have another gullet here.
Quite a bit of difference in size.
But the gullet is there for only one purpose, and that's to
Allow for the chip removal.
handling debris during the
Right.
cut. The larger the gullet, the better able it is to handle large amounts of debris or generate a faster cut.
So would necessarily a larger gullet denote a more coarse cut?
A rougher
cut.
faster cut.
Okay.
A smaller gullet would be a much finer, cleaner, slower cut.
Okay.
But typically the presence of more and smaller gullets means you've got a blade with more teeth.
Speaking of teeth, why does one blade have more teeth than another?
I don't know. Why does one blade have more teeth than another?
Well, a lot of people think that more teeth is better, but you have to understand that the relationship between the number of teeth and the diameter and the feed rate are really critical. In other words, if you have a blade with 20 teeth or 24 teeth, okay, and you can push it through at a rate that gives you a good clean cut, it's much different than having a blade with twice as many teeth that you push through at the same rate. What happens is like on an 80-tooth blade, this is a 60, I believe, but on an 80-tooth blade in solid surface, it'll give you a nice smooth cut, but what it's actually doing is grinding, because you actually can't push it fast enough for the blades to evacuate the material properly. So it's like a grinder in there. So an 80-tooth blade is not necessarily as good for a material like solid surface as a 60 or a 40-tooth. A 40-tooth can rough it out without any problem at all. A 60-tooth will give you a nice clean cut, but an 80-tooth will actually, I think, cause more damage to the blade because it's overheating, it's not removing the material properly.
We have a question. Somebody wants to know, how much heat should you expect a saw blade to generate? Is not too much heat a sign of a dull blade?
Well, not necessarily a dull blade. It could be a blade that doesn't have enough side clearance, wasn't manufactured properly. Yes, as they do get dull, they will generate more heat, and you'll notice that in the cut and what have you. And I'm sure you have, as well as I, have pushed the blade to where it looks like you're having a barbecue, but you need to get through that last piece.
That's right. The blade usually turns black at that point.
That's right, exactly. And remember, a dull blade is a very dangerous blade. You want to make sure that your blades are sharp. I cut my thumb down to the bone one time, and I happened to mention to the surgeon that I had just put a brand new blade on the saw, and he said that probably was the best thing I could have done because it cut fast and clean, where a dull blade, if it grabs your thumb or anything else, could just chew it up.
And once again, once your blade does begin to discolor, you've probably ruined it.
Right.
You've probably destroyed it, so it needs to be disposed of. Another feature to look for in a saw blade are right here, little plugs. Now these are copper plugs right here. And copper plugs, the reason why those are desirable to have in your saw blade is in conjunction with the expansion gullet, or not gullets, but the expansion slots, because this is a softer metal filling in that, it tends to quiet the blade down. So you don't get the whine from a blade, especially one running without cutting, where it's just making that wah.
Excuse me. Someone out there have a question?
You can't get good help anymore.
We're talking here. Is that okay? It's very distracting. Thank you.
For our ADHD members.
You know?
So, matter of fact, I'm going to let John explain the next feature too. So these are desirable, especially as you get into larger blades. The smaller blade, it's not as critical because there's so much less mass there to be worked with.
Right.
When you get into larger and larger blades, a feature like that becomes more desirable because you tend to get a lot more whine out of the saw blade, and that'll help tone it down. Something I never really knew about, and John instructed me on this, but I had it mentioned by saw manufacturers I talked to, are this ring running around the saw here, or, let me hold this one up real quickly.
This blade, this is an old blade, but
it's an old blade, but you can still see there are straight lines coming down at several points on the blade. And what's that for, John?
Well, they're tensioning marks, and different manufacturers have different ways of tensioning a blade. This one obviously puts a circle around the blade, but what it does is it takes the tension out of the blade so it makes it flat. And same with these. They relieve the tension of the blade from the outside edges, and it keeps the steel flat.
Okay, which is critical, once again, because if you have a blade that tends to take itself out of plane,
right,
then you basically have something you're just merely going to throw in the trash.
Right. And that's really critical, or it's something that you see when you're cutting things like plastic laminates, melamine products, not so much in wood. When you're cutting a piece of oak or something like that, you're really not going to notice a little tiny bit of run out in a blade on normal instances. But if you're cutting a hard product like pressure treated or high pressure laminate on particle board or MDF, or a melamine product, when you cut through that, if there's any waver in that blade, you're going to see it in the chipping in there. So it's good to have a good straight blade all the time. Now, if you don't have a straight blade, well, not if you don't have a straight blade, but if you're using like a thin kerf blade, let's see, this is actually a thin kerf blade, and it's very, very much thinner than a standard saw blade. And the reason they do this is to take away less material, and actually that makes a lot of difference in something like cutting an expensive exotic hardwood or expensive veneers. When you're cutting up a lot of strips, it makes a difference. But in that case, what you can do is use a saw stiffener, which we don't happen to have one tonight, but it's a piece of steel that lays on each side of the blade and clamps it so that
we actually have a drawing right there.
We have a drawing of it, but I don't know if you're going to really see that too well. But what it does is it clamps on each side of the blade, and only a portion of the blade that would be cutting is actually exposed in cutting the blade. The rest of it becomes a very thick material, and it also acts as a heat sink.
Mm-hmm. So it prevents, once again, it prevents the blade from twisting.
Right, exactly.
Although it still should be said, anytime you take your work, if you twist the work on the table, you are going to distort the blade and potentially just destroy it.
Absolutely, absolutely. When you're pushing a large sheet through and it all of a sudden bumps, it's like, that blade's pretty much shot. But, as always, we continue to use them until they're so dull that they smoke, and then we send them out.
Then they're dangerous.
And that's another thing, saw sharpeners are very hard to find. A lot of guys, and I don't want this to sound wrong, but a lot of guys will buy saw sharpening equipment, set up in their basement, and then they're going to go around from shop to shop saying, I'm a saw sharpener. Well, unless they're really qualified, they're not. And they can sharpen the blade, but most of them take off a lot of material if they're not experienced. So you want to go to a good sharpener. We happen to have one up in New York that I used when I was a fabricator in Buffalo, and I've always been using him since. And we have him as a saw surface, and they re-tip, they straighten the blades, they hammer them, they do everything they need to. They also sharpen spiral cutters, which we'll get into. So if you do need a good sharpening service, you can check our website or call our office. It's something that it'll prolong the life of your blades so much.
Now, very briefly, because we're almost out of time for this segment, some of the typical or the common types of saw teeth that you'll see out there are flat top, which it's just a flat top on the tooth of every blade.
Right.
That's only for ripping material.
That's correct.
And primarily wood.
Right.
Not wood products, but wood itself, like 2x4s and pine. Next, you would have an alternating top bevel, which we talked about earlier.
Right.
And that is going to be used for cross-cutting. That would be used for laminates, particle boards, a lot of things like that.
Right.
And the high alternating...
High AT. And those dull quickly. Mm-hmm. People need to know that. Your high AT blades dull quickly, but they're a good way to get the most out of the blade.
To cut chip-free.
Exactly.
Which is the critical part, and we'll talk about that.
Chip-free when they're sharp.
Exactly, and we're going to talk about that as we get into router bits a little bit more. Next would be triple chip grind and modified triple chip.
Right.
And we can talk about that some more after the break, because I know that's hanging over our heads.
Okay.
So we'll see you in just a minute.